You have been passing objects between functions and hoping they have the right methods. No contract, no enforcement, no warranty. I am Ahaz. Today in episode 23, ABC and Protocol, you will learn how to define interfaces in Python that enforce contracts. We will cover abstract base classes with the ABC module, the abstract method decorator to require method implementation, abstract properties using the property and abstract method combination, protocol for structural subtyping, and duck typing with type safety, the difference between nominal and structural subtyping, and runtime _ checkable for isinstance checks with protocol. By the end, you will have a fully typed shape render system. Let's go. Let's start with why ABC exists. Look at the left card, no interface. We define a base animal class with a speak method that just returns a string. Dog and cat inherit from animal. But what if someone forgets to override speak? The base class method silently runs and returns the wrong thing. No error. No warning. Bugs hide until runtime. Now look at the right card with ABC. We import ABC and abstract method. Animal inherits from ABC and marks speak as abstract method. Now, if dog forgets to implement speak, Python raises a type error at instantiation time, not later. You cannot even create a dog object without implementing all abstract methods. ABC turns silent bugs into loud, early errors. That is the contract. Let's write your first abstract base class. Import ABC and abstract method from the ABC module. Make your base class inherit from ABC. Decorate each method that must be implemented with @abstract method. Look at the code. We define a shape class inheriting from ABC. Area is decorated with abstract method. Every subclass must implement it. Perimeter is also abstract. Describe is a concrete method, not abstract. It is inherited as is. We define circle inheriting from shape. Circle implements area and perimeter. We define square inheriting from shape. Square implements area and perimeter. When you try to instantiate shape directly, type error. When you instantiate circle, works perfectly. This is the nominal subtyping contract. Explicit inheritance required. A real interface usually requires multiple methods. Let's define a full data store contract. Look at the code. We define data store inheriting from ABC. For abstract methods, connect, disconnect, read, and write. Each has a type signature. Read takes a key and returns optional of str. Write takes a key and value and returns bool. We define Redis store inheriting from data store. Redis store must implement all four methods, or Python raises type error. It implements connect, disconnect, read, and write. We define SQLite store also inheriting from data store. SQLite store provides its own implementations. Now any function that accepts a data store parameter is guaranteed. Both Redis and SQLite honor the contract. This is how you build plugin architectures in Python. What if the contract requires a property, not just a method? Use the combination of @property and @abstract method. Look at the code. We define a vehicle ABC. The fuel _ type property is decorated with both property and abstract method. The max _ speed property is also abstract. The describe method is concrete. It calls self.fuel _ type and self.max _ speed. We define electric car inheriting from vehicle. Electric car implements fuel _ type as a property, returning the string electric. It implements max _ speed, returning 200. We define gas car, implementing both differently. The describe method works on both. It calls the abstract properties polymorphically. Abstract properties enforce that subclasses expose a consistent interface, even for attribute-style access. Protocol is structural subtyping, duck typing with type safety. With ABC, the class must explicitly inherit from your ABC to pass isinstance. With protocol, any class that has the right methods qualifies. No inheritance needed. Look at the code. We import protocol from typing. We define a drawable protocol with a single draw method. Now circle and square do not inherit from drawable at all. They just have a draw method. The render function accepts any drawable, and both circle and square qualify. because they have draw. mypy checks this statically. If a class lacks the draw method, passing it to render is a type error. Protocol is how you write functions that accept anything with the right shape. The true spirit of duck typing, now with static type safety. When do you use ABC versus protocol? The answer depends on whether you control the classes. Look at the comparison. ABC. Use when you own the class hierarchy. Subclasses explicitly inherit from your ABC. Isinstance checks work without extra decoration. Shared implementation via concrete methods. Best for frameworks, plugin systems, base classes you ship. Protocol. Use when you do not own the classes. Third-party classes with the right methods qualify automatically. No inheritance required. Structural duck typing. Best for library code, functions that accept many object types, typing existing code without modifying it. In modern Python, prefer protocol for function parameters and ABC for class hierarchies you build. They are complementary, not competing. Protocol does not support isinstance checks by default. To enable them, decorate your protocol with @runtime_checkable. Look at the code. We import runtime_checkable from typing. We define a serializable protocol with _dict method. We add the @runtime_checkable decorator. Now isinstance of some object and serializable works at runtime. We define config with _dict method. Isinstance of config instance and serializable returns true. We define logger without _dict. Isinstance of logger instance and serializable returns false. Important warning. Runtime checkable only checks that the method exists. It does not check the signature. Use it for quick checks and defensive programming. Rely on mypy for full signature validation. Together, they give you both runtime safety and static type correctness. Our mini project, a typed shape render system. We define 3 components. First, the renderable protocol. It requires draw accepting a canvas string and returning none. It requires bounding _box returning a tuple of 4 floats. Second, the shape ABC. It provides a concrete label method. It has an abstract area method. Third, circle inherits from shape and implements renderable. It provides draw, bounding _box, and area. The render_all function accepts a list of renderable. Any object with draw and bounding _box qualifies. When you run mypy-strict on this module, 0 errors. This architecture separates rendering from geometry. You can add rectangles, polygons, SVG paths. As long as they implement renderable, the renderer accepts them. Your challenge: build a plugin system using ABC and protocol. Step 1. Define a logger ABC with 2 abstract methods. Log accepting a message string, and get _logs returning a list of str. Step 2. Define a formatter protocol with a single format method accepting a message string and returning str. Step 3. Implement console logger and file logger inheriting from logger. Step 4. Implement JSON formatter and plain formatter classes. No inheritance from formatter needed. Just implement the format method. Step 5. Write a process function that accepts a logger and a formatter and log a formatted message. Step 6. Add runtime_checkable to formatter and verify isinstance. Run mypy-strict. 0 errors required. Paste your code and mypy output in the comments. I read every single one. Let's recap what you learned today. ABC makes a class abstract. You cannot instantiate it directly. Abstract method marks methods that every subclass must implement. Python raises type error at instantiation if any abstract method is missing. Abstract properties combine @property and @abstract method decorators. Protocol defines structural interfaces, no inheritance required. Any class with the right method signatures satisfies a protocol. Runtime_checkable enables isinstance checks for protocols. ABC is for class hierarchies you own. Protocol is for types you do not. Use both together. Protocol for function parameters, ABC for base classes. The mini project showed a shape renderer with ABC plus protocol together. Next episode, Decorators Deep Dive, Functools, Wraps, Parameterized Decorators, Class Decorators. Subscribe so you don't miss it. See you tomorrow. ABC and Protocol. Mastered. Your Python interfaces are now enforced, typed, and professional. Subscribe for the next episode. Drop your logger plugin system in the comments. I am Ahaz. See you in episode 24.